In Java, method parameters are variables that are passed to a method when it is called. The method can use these parameters to perform its task and return a result. For example, consider the following method that calculates the area of a circle. Public static double get circle area, double radius. Return math.py *radius*radius. In this example, the method getCircleArea takes a single parameter radius of type double and returns the area of a circle with that radius. To call this method, you would pass a value as an argument. Double area equals getCircleArea, 3.0. System.out.println, area. This code would output 28.274333882308138. You can also pass multiple parameters to a method, for example, public static double get rectangle area, double length, double width. Return length * width. In this example, the method getRectangleArea takes two parameters length and width of type double and returns the area of a rectangle with those dimensions. You can call this method as follows. Double area equals getRectangleArea, 4.0, 5.0. System.out.println, area. This code would output 20.0. Java method overloading. Java supports method overloading, which allows multiple methods with the same name to be defined in a single class, as long as each method has a different number or type of parameters. For example, public class example. Public int add, int a, int b. Return a plus b. Public double add, double a, double b. Return a plus b. In this example, the class example has two methods with the same name add, but each takes different parameters. One takes two int values and returns an int, while the other takes two double values and returns a double. When you call the add method, Java determines which method to use based on the types and number of arguments you pass. For example, example equals new example. Int result1 equals example.add, 1, 2. Double result2 equals example.add, 1.0, 2.0. System.out.println, result1, /outputs 3. System.out.println, result2, /outputs 3.0. Method overloading allows you to write methods with the same name that perform similar tasks, but with different parameters, which can make your code easier to read and maintain. However, it is important to use method overloading carefully, as overloading can also make your code harder to understand if used excessively or in a confusing manner. Java scope. Java scope refers to the portion of the program where a variable, method, or class is accessible. In Java, you can define variables, methods, and classes at different levels of scope, which determines their accessibility throughout your code. There are three main levels of scope in Java. Class scope. Variables, methods, and inner classes defined at the class level have class scope, and are accessible from anywhere within the class. Method scope. Variables defined within a method have method scope, and are only accessible within that method. Block scope. Variables defined within a block of code, such as within an if statement or a loop, have block scope, and are only accessible within that block of code. It is important to understand scope in Java, as it can affect the behavior of your code. For example, if you try to access a variable that is defined in a method from outside of that method, you will get a compiler error, because the variable is not accessible outside of the method's scope. Here's an example of scope in Java. Public class example. Int x equals 10, / class scope. Public void print x. Int y equals 20, / method scope. System.out.println, x. System.out.println, y. In this example, the variable x has class scope, and is accessible from within the printx method. The variable y has method scope, and is only accessible within the printx method. If you try to access y from outside of the printx method, you will get a compiler error. Java recursion. Java recursion is a programming technique where a method calls itself to solve a problem. The idea behind recursion is to divide a problem into smaller, similar problems and solve each of them recursively. This can be done until the problem is reduced to a simple enough form that it can be solved directly. For example, integers from 1 to n. One way to solve this problem is to use recursion. Public int factorial, int n. If n equals 0, return 1. Else, return n asterisk factorial, n, 1. In this example, the factorial method calls itself with the argument n1 until n reaches 0. At that point, the base case is reached, and the method returns 1. The result of each call to factorial is then multiplied by n to obtain the final result. It is important to ensure that the recursion terminates and has a base case to avoid an infinite loop. A base case is the simplest form of a problem that can be solved directly, and it is usually defined using an if statement. Recursion can be a powerful tool in solving complex problems, but it is also important to use it carefully and understand its limitations, such as the risk of stack overflow due to excessive recursion. In general, it's a good idea to use iteration, such as a for loop, whenever possible, and only use recursion when it makes the solution more clear and elegant. Java OOP. Java is an object-oriented programming (OOP) language, which means that it provides features for creating and managing objects and classes. OOP is a programming paradigm based on the idea that software should be designed as a collection of objects, each representing a real-world entity. In Java, an object is an instance of a class, and a class is a blueprint that defines the properties and behaviors of objects. Classes define the data and the methods, functions, that operate on the data. Here's an example of a simple class in Java. Class dog. / instance variables, data. String breed. Int age. String name. / methods. Void bark. System.out.println, woof woof. Void run. System.out.println, the dog is running. In this example, the dog class has 3 instance variables breed, age, and name, and 2 methods bark and run. To create an object of the dog class, we would use the new operator, like this. Dog my dog equals new dog. My dog.breed equals Labrador. My dog.age equals 3. My dog.name equals Buddy. My dog.bark. My dog.run. In Java, OOP also provides features for encapsulation, inheritance, and polymorphism. Encapsulation means that the internal state of an object is hidden from the outside world, and the object exposes a well-defined interface for interacting with its state. Inheritance allows a new class to inherit the properties and behaviors of an existing class, while polymorphism allows objects to be treated as objects of their parent class. OOP is a powerful programming paradigm that allows you to model real-world objects and create complex and flexible software systems. Java provides a rich set of tools for OOP, making it an ideal choice for many applications. Java constructors. In Java, a constructor is a special type of method that is called when an object of a class is created. It is used to initialize the state of the object, and it has the same name as the class. A constructor can have parameters, and these parameters can be used to initialize the instance variables of the class. Here's an example of a class with a constructor. Class dog / instance variables, data, string breed, int age, string name, / constructor, public dog, string name, int age, string breed. This dot name equals name. This dot age equals age. This dot breed equals breed. / methods. Void bark. System.out.println, woof woof. Void run. System.out.println, the dog is running. In this example, the dog class has a constructor that takes 3 parameters, name, age, and breed. When we create an object of the dog class, we can pass values for these parameters to the constructor, like this. Dog my dog equals new dog, Buddy, 3, Labrador. My dog.bark. My dog.run. Java also provides a default constructor, which is a constructor that takes no parameters. If you don't define a constructor in your class, Java will automatically create a default constructor for you. Note that in Java, a class can have multiple constructors, as long as each constructor has a different number or types of parameters. This is called constructor overloading, and it allows you to provide different ways of initializing an object. Java modifiers. Java has several access modifiers, also known as visibility modifiers, that control the visibility and accessibility of class members, variables, methods, and inner classes, from other classes and objects. The main access modifiers in Java are public. A member with the public modifier is accessible from any class or object, regardless of the package it is in. Private. a member with the private modifier is only accessible within the same class in which it is declared. It is not accessible from any other class or object. Protected, a member with the protected modifier is accessible within the same class and its subclasses, regardless of the package they are in. Default, a member with the default modifier, also known as package private, is accessible within the same package, but not from any other package. Here's an example that demonstrates the use of access modifiers. Public class dog. Private string breed. Protected int age. Public string name. Public dog, string name, int age, string breed. This dot name equals name. This dot age equals age. This dot breed equals breed. Private void bark. System.out.println, woof woof. Protected void run. System.out.println, the dog is running. In this example, the breed variable is declared as private, so it can only be accessed.
In this example, the breed variable is declared as private, so it can only be accessed within the dog class. The age variable is declared as protected, so it can be accessed from any subclass of the dog class. The name variable is declared as public, so it can be accessed from any class or object. The bark method is declared as private, so it can only be called from within the dog class. The run method is declared as protected, so it can be called from any subclass of the dog class.
Java encapsulation is the process of wrapping data, variables, and behavior, methods, within a single unit or object, hiding the implementation details from the outside world. It's one of the four fundamental concepts of object-oriented programming, OOP, along with inheritance, polymorphism, and abstraction. Encapsulation is achieved in Java through the use of classes and access modifiers. By declaring variables as private and methods as public, it is possible to control the visibility and accessibility of data and behavior within a class. This provides a way to hide the internal details of a class, making it easier to maintain and change code in the future, while still providing access to the data and behavior that is necessary to interact with the object. Here's an example of encapsulation in Java. Public class dog. Private string breed. Private int age. Private string name. Public void set breed, string breed. This dot breed equals breed. Public string get breed. Return breed. Public void set age, int age. This dot age equals age. Public int get age. Return age. Public void set name, string name. This dot name equals name. Public string get name. Return name. In this example, the instance variables breed, age, and name are declared as private. This means that they cannot be directly accessed from outside the dog class. Instead, access to these variables is provided through public methods such as getBreed, getAge, setBreed, setAge, etc. These methods provide a way to read and modify the instance variables in a controlled manner, while still hiding the implementation details of the class. Java packages and API. Java packages are a way to organize related classes and interfaces into a single unit. It helps to reduce name collisions and make it easier to maintain and reuse code. A package in Java is defined using the package keyword followed by the package name. Classes and interfaces can be added to a package by simply including the package statement at the beginning of the source code file. Here's an example of a Java package. Package com example.animals. Public class dog. / class code goes here. The Java API, Application Programming Interface, is a collection of pre-written classes and interfaces that provide functionality for common programming tasks. It is an integral part of the Java platform and includes a large number of packages and classes that provide a wide range of functionality, from GUI programming and database access to networking and XML processing. For example, the java.util package includes classes for working with collections, such as ArrayList and HashMap. The java.io package includes classes for reading and writing files, such as file input stream and file output stream. The java.net package includes classes for networking, such as URL and socket. By using the Java API, developers can save time and reduce the amount of code they need to write by leveraging pre-existing, tested, and well-documented code. Additionally, because the Java API is part of the Java platform, it is portable and runs constantly on any platform that supports Java. Import a class. In Java, you can import a class from another package into your current class, which allows you to use the methods and variables of that class without having to qualify them with the full package name. The import statement is used to import a class from another package. The general syntax for importing a class is as follows. Import packagename.className. For example, to import the scanner class from the java.util package, you would use the following statement. Import java.utility_scanner. Then, in your code, you can use the scanner class without having to qualify it with the full package name. Scanner sc equals new scanner, system.in. Int x equals sc next int. It's worth noting that you can also import all classes from a package using a wildcard character *. Import java.utility*. However, it is generally recommended to import only the classes that you need, as this can improve performance and make your code easier to understand. Import a package. In Java, you can import a package to access the classes and interfaces within that package. The import statement is used to import a package into your code. The general syntax for importing a package is as follows. Import package name *. For example, to import all classes and interfaces from the java.util package, you would use the following statement. Import java.utility *. Then, in your code, you can use the classes and interfaces within the java.util package without having to qualify them with the full package name. Scanner sc equals new scanner, system.in. Int x equals sc next int. It's worth noting that you can also import individual classes from a package, as described in my previous answer. Importing individual classes can improve performance and make your code easier to understand, but importing a package can be useful when you need to access many classes within that package. Java inheritance. In Java, inheritance is a mechanism that allows one class to inherit the properties and behaviors of another class. The class that inherits the properties and behaviors is called the subclass, and the class from which the properties and behaviors are inherited is called the superclass. Inheritance provides several benefits, including code reuse and modularity. When a class inherits from another class, it inherits the fields and methods of the superclass, which can save you time and reduce the amount of code you need to write. This can also help to make your code more modular, since you can break down complex problems into smaller, more manageable parts. To create a subclass in Java, you use the extends keyword. For example, class bicycle / fields and methods. Class mountain bike extends bicycle / fields and methods specific to a mountain bike. In this example, the mountain bike class inherits from the bicycle class. This means that the mountain bike class has all the fields and methods of the bicycle class, as well as any fields and methods that are specific to a mountain bike. It's also worth noting that inheritance can be used to override methods from the superclass. This allows a subclass to provide a different implementation of a method from the superclass, while still maintaining the same interface. Overall, inheritance is a powerful feature in Java that can help you to write more maintainable, reusable, and modular code. Java polymorphism. Polymorphism is a fundamental concept in object-oriented programming, OOP, that allows objects of different types to be treated as objects of a common type. In Java, polymorphism is achieved through method overloading and method overriding. Method overloading. Method overloading in Java is the ability of a class to have two or more methods with the same name, but with different parameters. This is also known as method signature. Method overloading allows you to create multiple methods with the same name, but with different numbers or types of parameters. For example, class adder. Int add, int a, int b. Return a plus b. Double add, double a, double b. Return a plus b. Method overriding. Method overriding in Java is the ability of a subclass to provide a different implementation of a method from the superclass. When a method is overridden, the subclass provides a new implementation of the method, which replaces the implementation from the superclass. This allows a subclass to extend the functionality of a method from the superclass, or to provide a different implementation that is more specific to the subclass. Class animal. Void make sound. System.out.println, animal sound. Class dog extends animal. Void make sound. System.out.println, bark. The make sound method from the animal class, and provides a new implementation that is more specific to a dog. Polymorphism is a key feature of OOP that enables you to write code that is more flexible, reusable, and maintainable. It allows you to write generic code that can handle objects of different types in a consistent manner, making it easier to create complex programs. Java abstraction. Java abstraction is a process of hiding the implementation details and showing only the functionality to the users. It means that the internal representation of an object is hidden from the users, and they interact with the object only via its methods. The main goal of abstraction is to simplify the usage of an object and increase the security of the implementation by hiding the complexities of the code. Java supports abstraction through abstract classes and interfaces. Abstract classes and methods. An abstract class in Java is a class that cannot be instantiated on its own. It serves as a blueprint for creating concrete subclasses. An abstract class can have both abstract and concrete methods, which means methods with and without a body. Abstract methods are methods declared without a body in the abstract class. They only provide a method signature and require the concrete subclasses to provide the implementation. This allows subclasses to define the specific behavior according to their requirements while still maintaining the same method signature. To declare an abstract class, use the abstract keyword before the class declaration. To declare an abstract method, use the abstract keyword before the method signature and omit the method body. Interfaces. An interface in Java is a blueprint for a set of methods and constants. It defines a contract that is implemented by multiple classes. Unlike abstract classes, an interface cannot have instance variables and its methods are implicitly abstract. Interfaces are used to achieve multiple inheritance in Java, where a class can extend only one superclass but can implement multiple interfaces. An interface is declared using the interface keyword, followed by the interface name and a list of methods without bodies. Classes can implement an interface by using the implements keyword, followed by the interface name. The implementing class must provide a body for all the methods defined in the interface. Interfaces are commonly used to define common behaviors that must be implemented by multiple classes. For example, the java.lang.comparable interface defines a single method, compare2, that classes can use to implement natural ordering for their objects. Here is an example of an interface in Java. Interface shape. Double area. Double perimeter. Class rectangle implements shape. Private double length. Private double width. Rectangle, double length, double width. This dot length equals length. This dot width equals width. Public double area. Return length asterisk width. Public double perimeter. Return to asterisk, length plus width. Class circle implements shape. Private double radius. Circle, double radius. This dot radius equals radius. Public double area. Return math.pi asterisk radius asterisk radius. Public double perimeter. Return to asterisk math.pi asterisk radius. In this example, the shape interface defines two methods, area and perimeter. The rectangle and circle classes implement the shape interface and provide their own implementation for the methods defined in the interface. This allows objects of these classes to be used interchangeably, even though they have different internal representations. Java enums. An enum in Java is a type that represents a fixed set of constants. For example, you can use an enum to represent the days of the week. Enum days. Monday. Tuesday. Wednesday. Thursday. Friday. Saturday. Sunday. Here, the enum days defines the days of the week as a set of constants. These constants can be referred to using the dot notation, for example, days.Monday. Enums are more type-safe and readable than using integer constants or strings to represent the same values. You can also define fields, methods, and constructors inside an enum. Here's an example. Enum color. Red, red. Blue, blue. Green, green. Private string name. Color, string name. This dot name equals name. Public string getName. Return this .name. In this example, each constant of the color enum has an associated string value. You can access this value using the getName method. Java user input can be obtained using various methods such as scanner class, buffered reader class, or console class. The scanner class is the most commonly used method for reading user input from the keyboard. The scanner class is used to read a variety of data types, such as integers, doubles, and strings, from the standard input stream, system.in. The syntax for reading a value using the scanner class is scanner sc equals new scanner, system.in. Int value equals sc next int. Another way to get user input is by using the buffered reader class, which is typically used to read text input from the keyboard. The syntax for reading a value using the buffered reader class is buffered reader br equals new buffered reader, new input stream reader, system.in. String input equals br read line. The console class is a more specialized class for reading user input from the console. It can only be used if the application is run from the command line, not from an IDE. The syntax for reading a value using the console class is console equals system.console. String input equals console.readline. Input types. In Java, there are several ways to get input from the user. Some of the common input types are scanner class. This class provides several methods for reading various data types from the standard input stream, keyboard. Buffered reader class. This class can be used to read input from the keyboard. Console class. This class provides methods for reading input from the console. JOption pane class. This class is part of the Java Swing GUI toolkit and provides a pop-up dialog for input and output. In all of these methods, the user is prompted to enter information, and that information is then read into the program and can be used as needed. Java date and time. In Java, the java.utilityDate and java.time packages provide classes and methods for handling date and time. Java.utilityDate, this class represents a specific instant in time, with millisecond precision. It provides methods for setting, getting, and formatting dates and times. Java.time package, this package includes several classes for working with dates and times, such as local date, local date time, zone date time, and others. These classes provide a more advanced and flexible way of handling dates and times compared to Java.utilityDate. Some common operations with dates and times in Java include getting the current date and time, formatting dates and times to a specific format, parsing dates and times from strings, and performing arithmetic with dates and times. Display current date and time example. Here is an example of how to display the current date and time in Java using the java.time package. Import java.time.localDateTime. Import java.time.format.datetime formatter. Public class main. Public static void main, string args. Local datetime current equals local datetime.now. Datetime formatter equals datetime formatter.of pattern, ddmmyyyyhhmmss. String formatted equals current.format, formatter. System.out.println, current date and time, plus formatted. This example uses the local datetime.now method to get the current date and time, and the datetime formatter.of pattern method to specify the format of the date and time. The resulting string is then printed to the console using system.out.println. Java iterators. An iterator is an interface in Java that provides a means to access elements of a collection object in a sequential manner, one element at a time. It is used to traverse a collection of objects and perform operations on each object. An iterator provides methods to check if there are more elements in the collection, to move to the next element, and to get the current element. Java provides built-in iterators for several collection classes, including the ArrayList and LinkedList classes. To use an iterator, you can create an instance of it using the iterator method of the collection, and then use its next and hasNext methods to access the elements. Iterator example. Here's a simple example that demonstrates how to use an iterator to traverse a list of integers. Import java.utility ArrayList. Import java.utility iterator. Public class main. Public static void main, string args. ArrayList numbers equals new ArrayList. Numbers.add, 10. Numbers.add, 20. Numbers.add, 30. Iterator equals numbers.iterator. While, iterator.hasNext. Integer number equals iterator.next. System.out.println, number. In this example, we create an array list of integers and then get an iterator for the list using the iterator method. The while loop then uses the hasNext method to check if there are more elements in the list, and the next method to access the next element. The current element is then printed to the console. Java exceptions try, catch. Java provides exception handling mechanism to handle errors that occurs in the program during runtime, using try, catch blocks. A try block is used to enclose the code that might throw an exception. The catch block follows the try block and is used to handle the exception. If an exception is thrown in the try block, the exception is caught in the catch block and can be handled in an appropriate manner. The syntax of try, catch block is try / code that might throw an exception. Catch, exception type X. / code to handle the exception. The exception type is the type of exception being handled, for example, IO exception, arithmetic exception, null pointer exception, etc. Multiple catch blocks can be used with a single try block, each to handle different types of exceptions. Java Lambda expressions. Java Lambda expressions are anonymous functions that can be used to implement functional interfaces. They allow developers to write code in a more concise and readable manner. Lambda expressions can take input parameters and return a value, just like a regular method. They are written as parameters-expression or parameters-statements. Lambda expressions are useful when working with collections and the Stream API, as they can be passed as arguments to methods and used to perform operations on collections in a concise way. Example of Lambda expression. Here is a simple example of a Java Lambda expression. / define a functional interface with a single abstract method. Interface math operation. Int operation, int A, int B. Public class Lambda example. Public static void main, string args. / define two integers. Int A equals 10. Int B equals 5. / use a lambda expression to define an instance of the math operation interface. Math operation addition equals int x, int y, -x plus y. / use the instance of math operation to perform the operation. Int result equals addition dot operation, a, b. System.out.println, result, plus result. In this example, we define a functional interface called math operation that has a single abstract method operation. We then use a lambda expression to define an instance of math operation that performs addition. This instance is used to perform the addition operation on A and B, and the result is printed to the console. Java files. Java provides classes for reading and writing to files in the java.io package. The most commonly used classes for reading and writing to files are the file and file writer classes. The file class provides methods to access file information and perform operations such as renaming, deleting, and creating new files. The file writer class is used to write text to a file. Java also provides the buffered reader and buffered writer classes for reading and writing text to a file efficiently. Create a file. To create a file in Java, you can use the file class in the java.io package. The simplest way to create a file is by calling the createNewFile method on an instance of the file class and passing it the desired file name as a string. For example, import java.io.file. Import java.io.io exception. Public class main. Public static void main, string args. Try. File equals new file, example.txt. If file.createNewFile. System.out.println, file created, plus file.getName. Else. System.out.println, file already exists. Catch, IO exception E. System.out.println, an error occurred. E.print stack trace. Here is an example of reading a file in Java. Import java.io.bufferedReader. Import java.io.file. Import java.io.fileReader. Import java.io.io exception. Public class main. Public static void main, string args. File equals new file, example.txt. Try, buffered reader br equals new buffered reader, new file reader, file. String line. While, line equals br read line, equals null. System.out.println, line. Catch, IO exception E. System.out.println, error reading file, plus E.get message. Used to read the file line by line, and the try with resources statement is used to automatically close the file when done. The file class is used to represent the file on the file system, and the file reader class is used to read the contents of the file. If an error occurs during the reading of the file, an IO exception is thrown, which is caught and displayed to the user. Delete a file example. Here's an example of deleting a file in Java. Import java.io.file. Public class main. Public static void main, string args. File equals new file, example.txt. If, file.delete. System.out.println, file deleted successfully. Else. System.out.println, failed to delete the file. In this example, a file object is created with the file name example.txt. The delete method is then called on this object. If the file is deleted successfully, the message "file deleted successfully" is printed, otherwise "failed to delete the file" is printed. Thank you.